Been working at this for some time. Yesterday I got a lot of phone calls and it was very time consuming. So I'm sorry I didn't have this up earlier, but I just want to walk you through this part. So I've tried to actually slim down the whole thing about joins. That way I can kind of tell you what you need to hear. That way you can reason off of it. I've created two new tables. One is called homes, the other one is called tenants. So here's what homes look like. And tenants looks as follows. As you can see, there are nulls in both cases and there are addresses in both cases. And some of the things match up, some of them don't, and that's exactly what was intended. Reason why is that I can then start to show you how joins make a differentiation. Now, I'm sure there'll be further differentiation in the event that you should add in some addresses that are brand new, that are not listed in either table, or that are listed in only one table but not the other, or names that are brand new that are listed in only one table, not the other. By the way, I am posting this up so that you guys can have a copy of these tables as well as the script that I'm using. Just want to walk you through this one thing. In addition to the tables that I said I am loading up, I also am loading up a small discussion. You'll see the link in the actual pages that are available for download. The links that are available for download will be on Oracle's discussion of the ISO join standard. All right. So basically, if you were to look at their grammar, they discuss what joins would look like in this particular link right here. This part down here you don't have to look at. This part up here explains quite a bit, shows you what it is that you need to see. I'm going to now show you very quickly from my own console what I've done. Here I have a cross join. Cross joins says no invalid due to using on or using clause, right? You're not supposed to do that with a cross join. It's a simple Cartesian product. So here's how you get some errors. I know people may wonder, why am I doing that? I'm just doing that to show you why you may get errors when you think you have followed the syntax. Cross joins, you don't do that. There are certain joins you just don't do that with. Further down here, you're going to see select from tenants, joins, homes. All right. If you use join, such as this, with no qualifiers, it depends on which database system you're using. On MySQL, they'll behave like an inner join, but according to the ISO standard, that's not how it should behave. It should actually behave just like the cross join. All right. So that's what I am showing you. I hope you will remember that. Now, going back to my console again, I'm going to scroll further down. All right. This right here is a normal join with a using statement. All right. There are certain differences between the regular join statement using name. I said it was same as inner. Let me just put this down as a column. I'm sorry, as a comment. Didn't mean for that error to appear there. There you go. All right. Now, taking a closer look at inner joins, here's what we have. Up here, when I used the using statement, it worked as an inner join. When I did not use that clause, however, it worked as a cross join. I prefer that you actually specify your joins, that way you'll know what you're doing. Here is an inner join. Take a look. I've named tenants X, and I'm going to do an inner join on homes Y, where X and Y are the same, or at least the same in the name area. Now, one thing you should notice is that when you use the using join, the using clause, whatever's in these parentheses is not going to repeat within the outward join statement. All right. So I'm going to use the X and Y. Now you can see that there are four columns. This came from table A, that came from table B, but now you see how they match up. All right. Now, in the event that I didn't want to list those parts right there, I could have just said list A dot star. I just want to know what it matches up to in the left-hand table. Sorry, I should have said X dot star. I'm going to use X dot star because I want to know what it would match up to in the first table. I'm going to use Y dot star. I'm going to ask about what it matched up to in the right-hand table. All right. Of course, the outcome is the same. If I just use star, I'm going to get both tables. Okay, so that's what's going on there. Now, if you take a closer look at what I have here, so moving further down, here you'll see I have a case in which I am checking to see where the addresses match up. So this is a bit different. All right. Now, with my addresses matching up, I'm going to get a lot of the same answers, but that's because it's an inner join. Remember that. So an inner join is going to give me the cluster of items that are absolutely the same. However, for this third part, I'm going to get the empty set. Let's take a look. Down there, I have the empty set because there's nothing between the two that are null. Now, moving further down, I'm going to use my natural join again, and I'm going to see how it really does match up to the inner join. All right. Except I did not get double statements. Now, here's what you should see for the left-hand join. Please slow down and listen to this. I know I'm going pretty fast, but I'm hoping to get these things across to you quickly. So, for the left join, all right, we have a left-hand column. Our central column of all left-hand tables, meaning the column that's in common that we say we're joining on. All right, that central column for the first table listed, that one that we refer to as a.column key, that's going to be the one that's always listed as we match the join specification. All right, so take a look down here. If I say that x.name is going to be what I'm matching on, I'm always going to have x.name in my table. All right. So now, take a look at it. Here's what else I'm saying. It's going to be listed, but it's going to be listed only in the sense that they match the join specification. So everything from this part on, x name equals y name, using name, x address where x address is null, using address where x address is not null, that's the part that's going to decide from the normal join measures that are taken which of the columns or which of the selected rows are going to be returned to you. All right, so this part up here, this performs the operation. This takes the subset of the operation and returns it to you based off of what your specifications are. All right, so that includes everything after the on or using clauses, including equal signs, including wheres, including is null or is not null statements. I'll put in a few others. Let me just say it's also including the not equal sign. It's another way of saying not equals is like that. Also, if you have a theta join, less than, greater than or equals, that type of stuff. Let me just put here ETC. You know what the rundown is, all right? Anything matched by that is what you will get back. So that's why here when I get x name equals y name, as you can see, I got the left-hand column. Everything I took was from tenants, all right? So I got all the people whose names are there. But now if you take a look at what I have here, all right, I wanted to get everything back from my left-hand table, but I also wanted to get back the columns in which they matched, all right? So now you're seeing some nulls there, no problem. But at the very least, I want to make sure that this part here gets me the entries that I'm looking for. So not every person is matched up to an apartment, all right? And I also have certain cases that are null. As you can see, the addresses that are missing, I have previously above about 10 different addresses. They're not there. But the ones that have corresponding accounts are all there. Now, the reasons why you see these nulls is because I kept in all of the names, all right? I said I wanted to get all of the names, but I also said that I wanted to make sure that every entry that corresponded with a name was given back to me based off of whether or not x name equaled y name, all right? So now, this next part, this is using name, so I'm not going to get the names duplicated again. As you can see, it's the same as above, but it's without the column duplication. So I'm going to run that part, and now you can see what I'm getting. All right, so here the only thing that's different is the two addresses between the first and second table those address columns are different. In the second table, they would have been all full. However, they only match up with what matches in my left table. Now, if I use this part right here about the address being null on X, take a look. Here's what I get. So where the addresses were null, I'm now getting corresponding outputs. Now, in my second table, there are no places where the addresses are null. Remember, I have tenants and I have homes. So one of them stores all the people, the other one stores all the addresses. So that's what's going on there. Now I use the following, using address. Here I'm not talking about what address has to be equal to. The using clause, it's what I must use, what I must make sure of is that there is at least a column in each table with this particular column name. Right, so where X address is not null, I run that guy. Here's what I get. Okay. Now moving further for my right join, it's going to be the same thing, but instead, here's how it works. The outcome that I get is going to be dominant on the second table listed. So I could get many more rows returned to me, but some of them are going to be null. Right, the ones that are not going to be necessarily null are going to be the ones that correspond to the right table. So everything is going to be dominant based off of what's in the right table, the right-hand side, okay? So using that same rationale, let's use our right joins. All right, that's what I got. Sorry about that part right there. That would not have happened if I did not clip part of the comment. There you go. Here's the next part. Okay, so you can see how some of these names are now null because the address part is full. But the names, they weren't all addresses that have tenants. And in the other cases, we do not have always tenants who are matched to a home that they're looking for. So that's how this table works. Now I'm going to look for the cases in which the names are null. I'm going to get my right-hand side. There we go. And now I'm going to look for the parts that are not null. All right, so when we compare these to our Venn diagrams, here's what we have. This one would be the case in which we have items that are in common, regardless of whether or not they exist in the left-hand side. So this would be all the things in B, all right, based off of B's common column of name. Once again, we have everything based off of B. Finally here, however, we have a case in which we are looking for a right join, and it's okay if some of the stuff we have there is B only, right? So remember that we were dominant on the name part in the X table. So this is going to be B without the common material from A. All right, so that's that crescent moon right-hand side shape. And then right here we have the same thing, but instead we are looking for cases in which the name part is not null. Okay, so we're using name on both sides. The name is not null. This is B with parts of A inclusive. All right, so if you look at the Sql Join commands, here's what we have. This was the inner join. All right, so with my right joins, I'm showing you this is the part with B with some of A included. This is the part with B with parts of A excluded, right? So addresses only. If the tenants are null, it is what it is, but we're returning everything with the addresses. Here we're returning things with addresses. Sometimes there's going to be some tenants matched up. We're not checking to see if they match or not. So with the left-hand side, same thing. We don't care if the addresses match up. We care about getting everything that the names correspond to. Here we're getting the names as they correspond to cases in which they may not be matching certain names from B, right? Because B is heavy on the homes and addresses. So you may have names, but some of them may have nulls because the addresses that are in B don't necessarily match up to this part right here. Okay, so that's what you have right there. Now, just to make sure that you guys have everything you need, I did script to a SQL table script. All right, so you can import that if you remember how to use run script. I also do have the actual commands that I wrote out. Okay, so you can check these things on H2. All the best. Thanks for listening. Take care. And for the last time, goodbye. Now, I should tell you that some of these things really do matter a whole lot more, even beyond the scope of this course. I'm going to be putting up videos in the summer, during the summer break, because these things still do matter. And some of these clauses here, the joins, they weren't always implemented in every little thing. Different database management systems have different levels of dedication to detail. If you feel like you should try out certain other SQL offerings, you already know about MySQL, Postgres, that type of thing. But here's something really cool that I found recently. It's called Beekeeper Studio. And if you remember my point for using H2, it was so that you guys would not have to learn system administration just to learn SQL. Here's another workaround. I wish I had seen this sooner, but I'm still happy I used H2 because it really it goes well with the Java programming that most schools are transitioning into. So it's just like a twofer basically, right? Still, this is one other way for you to learn about other database management systems such as MySQL, MariaDB, Postgres, Ingress, now known as Actium, and Oracle, perhaps MS SQL Server. I haven't really checked each and every last thing it works with, but I know it works with quite a bit. All right. So, all the best. Some of these details that you have, you should hold on to in life. They may work with things such as certain cases of merge statements and updates and things of that nature. Merge statements are another type of statement that's not always uniformly implemented. I should also tell you that some of the things I had to do in order to create these particular items here in my DBS or my database management system, in order to get these things up and running, I had to create two types of relational variables, right? We talked about relational variables, things like databases, schema, data warehouses, tables, views, columns. Clearly, I had to create both columns and tables just so I could get this data implemented. Schema was not necessary. Schema is a nice thing to have up your sleeve because it allows you to store things like triggers, stored procedures, tables, other lower level relational variables, as well as storage engines and so forth in a separate workspace. All right, so it's like the equivalent of a workspace. Now, as you can see here, the tables, they only have two columns. I didn't match anything together, but I knew that they would work. All right. In the event that you're using the using statement, they're going to expect you to have columns common to both tables where the name or the word name is actually the name of the column, like this guy right here. All right. Address would have worked the same way. If I say x.name equals y.name, then I'm claiming that there were two different, or actually it didn't need that to be x.name. Could have been any two columns, but I'm claiming that there were two columns that are comparable, right? The only way that I can be certain, however, and let me just make this clear, as you can see here in the general case, I don't have to have any sort of specific measure to make sure that the joins will work out. Sometimes they will, sometimes they won't. But if you want to make certain that they always will, the best way that you can do that is by using a foreign key between the two tables, so that the foreign key of one table will point to the primary key of another, and given the referential integrity, the actual entries into the primary key table will be a constraint on what you can put into the foreign keys entries for the foreign keys table. All right. So that's how you get your joins to work if you really must make sure that they are foolproofed. I am going to now say thank you for listening and goodbye.